The main focus of this video is not the continuity of the function but continuity with respect to differentiability. But for those who do not have any idea of continuity, in the simplest words, in a function graph, if there is no break or gap in the entire interval, then the function is continuous. Otherwise, if there is some gap, then the function is non-continuous. And in respective of differentiability, if a function is differentiable at some point, then the function must also be continuous at that particular point. And we can prove this statement by proving that a non-continuous function cannot have a derivative at the point of discontinuity. For the proof, consider a step function, whose function value equals 1 for all x less than a, and whose function value is equal to 10 for all x greater than or equal to a. So by the definition of derivatives, it is the slope of the tangent line at the function value point. And the simplest procedure to find the value of the tangent slope is to calculate the slope of the secant line between the function point at a and the function point at a minus h, and then taking the limit of h to 0. The slope of the tangent line or the derivative at the point a turns out to be undefined, which proves our point that if a function is differentiable at some point, then it must also be continuous. But this statement should be handled carefully. It states that every differentiable function is continuous, but the converse of this statement is not always true. So there are some cases in which a function, while remaining continuous in its complete domain, is non-differentiable at some points. To elaborate, consider the example of absolute value function. This function is continuous at x equals 0, but is not differentiable there. And we can prove this point by considering the slope of the secant line on both sides of the point 0. If we consider the slope of the secant line at the right side of the point at 0, it turns out to be 1. And if we keep on decreasing the value of h, the slope remains equal to 1. So in the limiting case, when h approaches 0, the derivative equals 1. And we can perform the same reasoning on the other side of the point, in which case slope turns out to be negative 1. And this time in the limiting case, the derivative turns out to be negative 1 at x equals 0. So as the derivative cannot be both 1 and negative 1 at the same point, so the derivative does not exist at x equals 0. And even a function with a smooth curve can be non-differentiable at some points, if the tangent at that point is a vertical line. For example, the cube root of x graph. At x equals 0, the tangent line on the graph gets too steep and vertical, and the slope becomes undefined, and so do the derivative. So in the conclusion, a differentiable function is always continuous in its entire domain, but there are some continuous functions that do not have a derivative.